In this lecture, we are going to look at graph sets with multiple selections. Here is an example of a graph set with multiple selections. From step number 5, we can go into step number 6, or step number 8, or step number 9. To go into step number 6, condition X must be satisfied. To go into step number 8, condition Y must be satisfied. To go into step number 9, condition Z must be satisfied. We notice that at the end, these pathways will lead into a single pathway through step number 11. In the first path, from step number 7, we go into step number 11 if condition G is satisfied. In the second path, from step number 8, we go into step number 11 if condition C is satisfied. In the third path, from step number 10, we go into step number 11 if the condition D is satisfied. This is the corresponding ladder program. The first network is a ladder rung that makes the system go into step number 5. It also has got conditions that are used to latch and kill step number 5. The second network is a ladder rung that makes the system go into step 6 when condition X is satisfied, whilst the system is in step number 5. The third network is a ladder rung that is used for the transition within the first path of the graph set. The fourth network is a rung that is used to make the system go into step 8 when condition Y is satisfied, whilst it is in step 5. The fifth network is a rung that is used to make the system go into step number 9 when condition Z is satisfied, whilst the system is in step number 5. The next network is a rung that is used for transitions within the third path of the graph set. The next network is a rung that is used to go into step number 11 from steps 7, 8, and 10 when respective conditions are satisfied. Note that also in each of these networks, there's a path for latching and killing each step. Let's have a look at some types of transitions that can be found in graph sets with multiple selections. The first graph set shows a case when the transitions are mutually exclusive. No transition will occur if both conditions exist or if none of the conditions exist. The transition from 12 to 13 will be cleared if condition B is satisfied and condition A is not satisfied. The transition from step number 12 to step number 14 will be cleared if the condition A exists and condition B is not satisfied. The second graph set shows the case when one of the transitions has a higher priority than the other. In this case, the transition from 12 to 13 has higher priority than the transition from 12 to 14. The transition from 12 to 13 will be cleared if condition A is satisfied irregardless of the state of condition B. The transition from 12 to 14 will only also be cleared if both the conditions A and B are satisfied. As an exercise, develop the corresponding ladder programs for these two graph sets. You can optionally upload your solution onto the Google Classroom platform. The third case shows a situation when there's need to jump over a set of steps. In this example, the system jumps from step number 12 to step number 15 if conditions F and E are satisfied whilst in step number 12. Effectively, we would have jumped the steps 13 and 14. Also, develop the corresponding ladder program and optionally upload onto the Google Classroom platform. A fourth case is a situation when we want to loop back to a previous step. In this example, the system will loop back from step number 18 to step number 17 if the condition N is satisfied and condition M is not satisfied. So effectively, it will be looping back between steps 17 and 18. Again, develop the corresponding ladder program and optional upload onto the Google Classroom platform. Let's have a look at the coin tosser as an example. In the first step, the coin is tossed. And depending on whether the head or the tail is shown, we transition from step number 1 to either step 2 or step 3. We have actions that will occur in these two respective steps. After 3 seconds, while it's in either step 2 or in step 3, the system transitions into step number 1 to begin another cycle. Here is the corresponding ladder program for the coin tosser. You can go on to have a further study of this program so that you understand how it relates to the graph set that we just described. And here is the I/O listing for the coin tosser. It shows the I/O addresses for the inputs and the outputs that are used with the system when it is run using a PLC. Here is an exercise. You are given a graph set and you are required to develop the corresponding ladder program. Please attempt this question and optionally upload your response through the Google Classroom platform.